Here we go. Our objective for today, I can change numbers from standard form to scientific notation and vice versa. Let's read together. 1, 2, 3. I can change numbers from standard form to scientific notation and vice versa. Copy that at the bottom left of your notes. All right, so we don't need a Freire model. The Freire model, we already started on scientific notation some time back, right? So it looks something like this. Scientific notation, we said it was a method of expressing very large numbers in smaller numbers. And they look like this. And what did we see? That they need to have one digit on the left side of the decimal. Is that correct? And all of them have base 10. Remember this? And I give you guys non-examples. And we wrote it has to be decimal times base 10. Okay? So from there, we started with these. Let's see if you remember. Here it goes. The process for these were you write the number down. When you multiply, this is base 10, so then you need to look at the decimal, which is right here, and you need to move it 4 times to the right. 1, 2, 3, 4. Add zeros. So my new number is 140,000. Remember that? Yeah, we did this already, right? Same thing with this one, 2.5, and now we're going to move the decimal how many times? 5 to the right, 1, 2, 3, 4, 5. Add some zeros, so therefore this is 250,000, and that's what we did before, right? But notice that the exponents were all what? Positives, right? And yesterday you did an intro on the online website with the negative exponents, is that correct? So let me just, to clarify that, so let's say these are negative. Therefore, the process goes as follows. You write the number down again. There's my decimal. So on the previous one, we went to the right. Is that correct? For positive numbers. Well, for this one, we're going to the left. How many steps? 4. 1, 2, 3, 4. Add 2 zeros. So my new decimal number is 0014. Everybody there? We got 2.5. We got 2.5, and we're moving the. Sorry, we're moving. Let me pause this. All right, here we go. So we're moving the decimal. How many steps to the left? 5. 1, 2, 3, 4, 5. Add zeros to the empty spaces, so my new number is 0.000025. You see what we're doing? All right, so copy these next two in your on your paper. Example C and D. Let's see how you do with those. Copy that and go. Okay, let's see. Can you give me the new number for this one? All right, Jimena. Hold on. 0. How many zeros? 1, 2, 3, 4, 5, 6, 7 zeros, and 2, 7. Hands if you got that. That is correct. How about this next one, Antonio? Hold on. Point. How many zeros? 4. 1, 2, 3, 4. 5. 386. Hands if you got that. That is correct. So once again, just to double check, we have to move the decimal the amount of times to the left if it's a negative. So this one we moved it 1, 2, 3, 4, 5, 6, 7, 8, 9. Therefore, we have 7 zeros. This one we moved 7 times, so therefore it's 1, 2, 3, 4, 5, 6, 7. So we got 1, 2, 3, 4, 5 zeros. And that's how we get that. Are we there? All right. So now I'm going to send you these next two on your Nearpod. on your iPad. So these two you're going to do on the screen. Hold on. Let me just pause this really quick. Copy those, and you can work on those. Okay, look up to the screen. Do you agree with those answers?
No, I do. No, there's no decimal.
It's missing the what? Decimal. Make sure you write your decimal at the end of each number. This one, let's see, we moved it 4 times, so that needs to have 3 zeros, right? This one we moved it 12 times, but these are 3 spaces, so how many zeros do we need to have? 9. 3, 6, 9. Yep. 3, 6, 9, and what? How about this one? What do you think? What was the mistake on this one?
They counted the 4.
They counted the 4, of course, but what else?
No, 9.
They counted the 9 and the 4. Do you guys see that? That could have been a mistake. So make sure you start from the decimal and start counting. Okay? Wow. It needs a decimal right here.
Oh, I did it on the other one though.
Okay? Well, it looks like it's missing no decimal. Everybody pretty much, my goodness, put the decimal on there. Does everyone understand? Make sure you write your decimal. Okay? All right, we got this, right? Yes, Mr. Q. All right. So, now let's go back to this one. Get your papers in front of you, please. So, this one, you don't have to copy this one yet, but let me go over this one. This one is from the previous lesson. This one, they're asking you to change this standard form into scientific notation. So this is the process. Look up, please. So the process, if you remember, was like this. Look up. I put the decimal here. And I need to move it 1, 2, 3, 4, 5 times. So then it's 2.35489 times 10 to the 5th. Remember that?
Yes.
Okay. But notice that we're moving it to the left, right? Okay. So, no, it has to be positive because we're changing it from standard to scientific. So now watch. Look at this next one. Oh, sorry. Look at this one. Pay attention, please, eyes up here. Guys, eyes up there. Here we go. Look at this one. Change to scientific notation. But now the decimal needs to go to the right instead of to the left. So if we move this to the right, 1, 2, 3, 4. So that means 2.569 times 10. Look up. Look at the one I just did right now. I moved it to the left, and it was a positive 5. This one I move it to the right, therefore this is what? Negative. How many times? 1, 2, 3, 4. You see how that worked? All right, copy this next one, please. Example 2B. Example 2B, and do that one by yourself, please, on your paper. Let's see. What'd you get for this one? Michaela, what was your number? 9.7325 times 10 to the power of negative 6. Let's see. 1, 2, 3, 4, 5, 6. And it's going to the right, so it is the negative. Hands if you got that. That is correct. Everybody got it?
Yes.
Fairly simple, right? It's just doing the opposite of what we did with the positives. So I'm going to send you these next ones on your Nearpod. For the people watching the video, copy those, do those by yourself. Here goes the correct answers on your screen. Hands if you got that by yourself. Be nice. Pretty good, right? Okay. Everybody got that? All right. Let's see. How about this one? I'm going to send to your screen. Is that one also correct? Do you agree that that's also correct? It is correct. 1.0 is the same as 1. Is that correct? Yeah, so don't get confused with those also. Let's see. How about let's look at this one. Okay. So which one is not correct? Why not?
Because he put the decimal in the wrong place.
In order to be a scientific notation, we need a digit on the left of the decimal. Is that correct? So it just needed to go one more step. Okay? And how about this one?
I forgot to put negative in the decimal.
Okay. So what were the mistakes on this one? No negative, and they needed to go one more step in order to go from 15 to 13, right? And then to make it a decimal, it's 2.3. Okay? So we got these, right? All right, good. So, with that said, look at this next one. It says a certain cell has a diameter approximately of 4.11 times 10 to the negative fifth. Let me zoom in. And another one has diameter of 1.5 times 10 to the negative fifth. Do you guys notice that these two, look up to the screen, these two are the same? When you have two numbers or scientific notation that are the same, then you need to focus on this number. Yes? So now, let's elaborate. So let's go with this one, 4.11. And I'm going to move it how many times? 5 to the 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay? And then this one is 1.5. And I move it 5. 1, 2, 3, 4, 5. Notice that they have the same amount of zeros in front. Is that correct? So therefore, it's asking, which cell has a greater diameter? Which number is greater, the 4 or the 1? Everyone? The 4 is greater, so this one's the greatest. So what can we conclude? That if they have the same base 10, you just look at the decimal number and you go with the biggest one. Everyone understand so far? But what if we had something like this? Watch. What if we had this number? Let's say we had 45.28 times 10 to the negative 6 and 1.6. And make some room here. Times 10 to the negative 2. Which number, look up please, which number is greater? Which one would you think is greater? First of all, you will think that the 45 is greater, is that correct? Because this one's only 1.6. But these are not the same. Therefore, watch, let's compare. This one is 6 times, so that means I'm going to go 1, 2, 3, 4, 5, 6. 1, 2, 3. How many zeros? 4. Okay? Let me do this one. Twice. 1, 2. How many zeros? 1. Therefore, Which number is greater, this one or this one? Which one is bigger? 0.16. This one is greater because it's closer to 1. This one is farthest to 1. So what can we conclude from these? That the smallest the negative exponent, the greater the number. Everybody understand that? Okay. So what if we have this? How about 2.38 times 10 to the 5th and 45.3 times 10 to the 2nd? Which one would be the greatest number? In this case, it's not this one because these are positive exponents. So the biggest number will be this one. Everyone understand? So the biggest number when the exponent is smaller, it only qualifies when it's a negative. Does everybody understand? All right, let's see if you can do this next one by yourself. Look at this one. It says, a star has a diameter of approximately 5.11 times 10 to the 3rd kilometers, and a second star has a diameter of 5 times 10 to the 4th kilometers. Which star is a greater diameter? Which star is bigger? So figure that one out. Copy that. Do that one by yourself. All right, so the correct answer was the second one. Everybody got it? All right, so with that said, you still have paper, right? All right, let's get ready for the partie. I know. Here it goes. It's going to be on your screen. Copy those problems. Home plate for tonight is found on page 482. Enjoy your home play. See you guys tomorrow.